So we are going to start Unit 9, which is about slope fields and separable differential equations. So slope fields, this is going to be a quick lesson. Basically, if you take a differential equation, which is really just a fancy word for a derivative, okay? I'm going to let the derivative function equal 2x. So we know if we would integrate this, we would get y equals x squared plus c. So this represents, because we don't know our constant of integration, we can have a whole family of functions, like x squared plus 2, x squared minus 3. We don't know until we find that value of c. So what we can see over to the right is we can see what is called a slope field or a directional field. In math, we call them slope fields. But it kind of, you see they're short little segments that kind of follow a pattern, and if you, in your mind, you can kind of mentally connect them to see the whole family of different functions you could have with x squared, all right? And so we could also sketch a particular solution. So if I said sketch a solution that goes through the initial point, -1, -1, then you would go to where that is, and you don't want to go through all the lines exactly, but you want to hit a few, and you kind of want to follow the pattern. Okay, so I kind of think of it like when the ocean makes all those ripples, like you can go through the currents and you might hit a few of the high points, but that's the idea, okay? So on our slope field, we are going to be given specific points, and typically they're going to be around the origin, and they're going to be pretty simple differential equations for you to use. And there's typically a pattern. So because it's time consuming, you just want to do the integer values that are on the graph. All right, so let's go ahead and do example 1. Now, as you make your slope fields, there's two things we'll be looking for. Obviously, zero slopes, undefined slopes, which remember, zero slopes would be horizontal lines, undefined slopes would be vertical lines. Sometimes you might see a vertical line or you might see it blank. I prefer the vertical line to show that you actually did the slope field there. And then you want to do positive slopes, and you want to show the degree of change by making them steeper with respect to what you've categorized, all right? Same thing with negative slopes. Show that it increases or decreases using the steepness, I'm sorry, that one's not negative, compared to each other, all right? And that's really how it's going to be graded. So let's look at example number 1. And by the end of this, you'll kind of see some patterns. So I tell you that the differential equation is x plus 1. So you can make a table of values. You can organize this in your head. It really is your choice. But if I'm given a differential equation with just x, that means I can only use x for my endpoint, and then I'm going to have my slope value, dy dx, all right? And so what you're going to notice is, like, if I pick this point right here, I've got in my head 0, 0, and I'm only concerned with the x value of 0. So if I plug in x is 0 right there, I get 0 plus 1. So at this point, I should have a slope of 1. So I know that's about a 45-degree angle, and I'm just going to estimate that, okay? You don't need to write the value next to it at all. That's kind of for your own information. So I get a slope of 1. Now, this point would also be 0, 1, and we don't care about the y value because our slope is only dependent on the x value. So all of these, you're going to try to do your best to make them look exactly the same as that one, okay? And so quickly, we just did 5 slopes. So I'm going to go to another point, and it's just random. I'll go to the next one. So that point is at 1, 0. So I get x equals 1, and so 1 plus 1 has a slope of 2. Now, if you've already judged this one to be a slope of 1, then you need to compare how would a slope of 2 rate. And the answer is it should be a little bit steeper. So don't make it crazy steeper, just make it a little bit steeper. So I'm going to just do like this. And all of these would be the same. Okay? So see, if your one doesn't look like exactly 45 degrees, that's fine too. So you just want to kind of compare them with respect to each other. Now I'm going to pick the next row, which means x equals 2. And so 2 plus 1 gives me a slope of 3. And so that should be even steeper. So, oops, I'm going to try to make it steeper. And that's why they only do a couple of points, because it really is hard to keep going with this idea. All right, now we're going to go to -1. So -1 plus 1 would be a slope of 0. So this should be completely horizontal for all of these. And then -2. -2 plus 1 would give me a slope of -1. And so this is my only negative. So there's really not much to compare it to. Just make sure you have a negative slope. All right, and so that would be our general slope field. Okay, and you can kind of see it would really create a parabola pattern over here. All right, let's try example number 2. So example number 2, our slope field is based on 2 times the y value. And so just like we did with the x value, now they're all going to be the same for the same y values. So I'll just make a little table. And we'll just pick this one. So actually, I'd like to start at 0. So if I pick 0 for all this y values, I get 2 times 0, which gives me a slope field of 0. But see, they're just little segments. These y values are 1, all of these. So I'd get a slope value of 2. And so we're just going to say, sure. I know that might look like 1. That's fine. Remember, it's all relative. And then these y values are at 2. You want to leave a little room to show the difference. So 2 times 2 would give me a slope of 4. So this should be steeper. And that's really all they're looking for. -1. So -2. And then look ahead. I know I'm going to need -4. So we'll make this -2. And then if x equals -2, we get -4. So this should be even steeper. And you might not be able to tell what this would look like, but that's okay. All right, example 3 is probably the most time consuming, but there is a pattern to this one too. This one's dependent on x and y. So it'll take a little bit more table work, dy dx. If you just want to use ordered pairs, you're welcome to. So at 0, 0, I get 0 plus 0 is 0. And so then I think, oh, well, what if I pick this value, 1, 0. So 1, 0. So if x is 1 and y is 0, so 1 plus 0 is 1. And so I'll just make this 45. And until you see the pattern, you might just be doing these randomly. So I'll just pick this one, which is 1, 1. So 1 plus 1 is 2. Make this a little steeper. This one, 0, 1, is 1. And so I should match it with that. And so it's like, oh, okay. Let's try this one, -1, 0. So I get -1. -1, 1. Add those together, we get 0. And so then I think, oh, if I have opposite numbers, so at -2, 2, at 2, -2. And so this one, and also 1, -1. So this one, I see the pattern's going to kind of be diagonal. Okay, so then I can kind of cheat a little bit and save myself some time. This was at 2. And so then I might need to find these. So let's see, I've got -1, -1, which is -2. So make this even steeper. And then I can do all my diagonals. And then my next one would be at -2, -1, which gives me -3. Make this even steeper. And then -2, -2 is -4. And I know it's really hard, but you can see it is a little steeper. This one's at 1, 2, 1, which is 3. And then 2, 2, so it's not vertical, but it is really steep. Okay, so obviously it's going to be quicker if you have just one variable, but you can do it with 2. All right, typically on an AP test, it's like 9 points. So I did a lot here so you can get the idea. On your student practice, I just did these to get you in the habit. And then I asked you some questions because this is matching. So these might even take longer because you've got to find some key points that can help distinguish which function it might be. Okay? And that's kind of how the multiple choice would look. So these questions are definitely multiple choice and typically free response as well. All right, so good luck.